I'll be going over the umpire process for merge sorted array. So for understand, so we're given two integer arrays. We're given two integer arrays called nums1 and nums2. And we also know they're sorted in non-decreasing order. And then we have two integers, m and n, which represent the number of elements in nums1 and nums2 respectively. So we have two integers, m and n, which are the number of elements in nums1 and nums2. Then our output, should be a merged sorted array. Merged sorted array of nums1 and nums2, but stored inside the array nums1. So for some examples, if we're given nums1 equals 1, 2, 3, 0, 0, 0, and then m equals 3, and two integers m and n representing number of elements. Well, if we just given 3, must be the number of elements that need to be switched. Let me see. The final stored array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. So where the first m elements denote the elements that should be merged. So like in this case, there are 3 zeros at the end, so I think this is something kind of different here. But yeah, I think it's the number of elements that need to be merged in the first array. So m equals 3, and then nums2 equals 2, 5, and 6, and n equals 3. So then the output should be 1, 2, 2, 3, 5, 6. Yeah, because we merge 2, 5, 6 into 1, 2, 3. So I mean we have 3 zeros, so we have to merge 3 times. So 1, 2, 2, 3, and then 5, 6. And then so for a second example, if we have nums1 equals 1 and m equals 1, then nums2 is empty, and n will be 0. Then it should just be, our output should just be 1. Output equals 1. Then finally, if we have nums1 equals 0, m equals 0, nums2 equals 1, and n equals 1, then our output should be 1. Okay, so for match, I don't think I've seen this problem before, but this has like sorting. I think we would use pointers of some sort. So pointers for the different elements in each array. So sorting, pointers. We're dealing with arrays, right? So for my plan, so well, I have some experience with this problem, obviously, right? So so there are some cases, I believe, that aren't in here when we have zeros in the array, and they're not going to be they're not just going to be just replaced. You want to keep them in the array. So I'd have to like change my solution a little bit from what I originally thought the first time. So I think the best way to go about it would just be to go from the end of the array of at least in nums1. So we can create two pointer variables. So create two pointer variables, and then one is equal to the last element in nums1, while the other pointer equals the first element in nums2. And then we could just have a loop that goes while it's less than n, which is the length of our nums2. So, because those are all going to be the elements that are merged into the first array. So, create a loop that goes until n, and so if the element in nums1 is equal to 0, have it equal the first element, the element at our pointer in nums2. And then we want to increase our nums2 pointer. Otherwise, we just want to decrease. Well, I don't think we need else. So increase our nums2 pointer, and then decrease our nums1 pointer, and then just sort nums1 at the end of the loop. So yeah, I'll try to implement this. So we can have our nums1 index equals len nums1 minus 1, and nums2 index equals 0. And then so while nums2 index is less than n, if nums1 index nums1 index equals 0, then we want it to equal the value at our nums2 index. So nums1 index equals nums2 index. And then we want to increase our pointer. So we want to decrease our nums1 index pointers. So nums1 index minus equals 1. And then nums2 index plus equals 1. And then we just want to just sort nums1. Sort. So we'll have the correct order of an array. So I'll sort it. I got it. And then yeah, looks like I was able to get the test cases. So I don't think it's the most efficient though, mainly because I was using the sorting right here. So in terms of evaluate, I'm not entirely sure, but because we're going off the input size of m and m, so I think that's what we use. So time is O of m plus n, right? The number of, well, I think it actually depends on n, right? Because we're, well, I guess the thing is we're sorting it. So yeah, it depends on the length of our nums1 array. So it depends how long our nums1 array will be, and then how long it takes to sort it. But this loop uses the n, so I guess it's O plus m plus n. But I know if you're using sort, it's like we'd use logs, so it might be O m plus n. And then log of m plus n. But the space, I believe, is constant. It's just O of 1 because we use these pointers, but I mean, we just use them in the loop, but this doesn't take up any other space. We don't create like another variable that we return or anything. We just sort our nums1 array. So thank you. That's my Umpire process for merge sorted array.